In this video, we are going to review Unit 10, question number 4 and 9. Okay, so let's start with question number 4. Now, if you take a look at the question itself, you're going to see that the book kind of hints to you how to start. It says, what is the area of the basement of the lake house, including the foundation? Ignore the slight irregularities in the shape of the foundation. For ease in calculating, divide the foundation into rectangles or squares. So you see over here that it kind of showed you how it divided those spaces. So let me show you on the larger floor plan now. What it's doing is dividing up all of those spaces. And this is typically what you're going to do, especially when you get to cost estimating. So this is going to become one shape, okay? And we're going to use that as a calculation. Then we've got another shape over here. That's another calculation. We have a shape down here where we're just going to square it off, right? It's saying ignore this irregularity right there. And then we have another shape down here. And we're going to square that off. You could also, if it's easier for you, when I calculated it, I just took this entire rectangle and made it one, and then this one up here. But I'll do it the way the book is showing, just for consistency's sake. So let's start with the pink box. Okay, and it says to include the foundation. So we have to look at the dimension here. So we have a dimension of, oops, sorry you can't see that. Let me move this up. We have a dimension of 28 feet 3 inches. But notice that that dimension is running, let's see where it's running. It's running from the edge of the foundation over here, and then it goes to the edge of the foundation over here. So that's okay. So we're going to do 28 foot, and I'm going to just draw another shape to help me. This dimension is 28 feet 3 inches. And this dimension right here is going to be, we have to look at the dimensions on the side. So we have one dimension that's starts here, and then it goes over to here, 28 feet 3 inches. So it is a square. So this is also 28 feet 3 inches. And it wants to know, we're looking for the area. So the area is going to be length times width. So we're going to do 28 feet 3 inches times 28 feet 3 inches, and that will give us length times width. That'll give us the area. DeWalt construction calculator on my phone, and if you bought a construction calculator, this is pretty similar, but I'm going to type in 28 feet 3 inches times 28 feet 3 inches, and then I get 798.0625 feet squared. And we will reduce that down in just a minute, but let's go ahead and leave that, put that to the side. Alright, so that's the pink box, the area of the pink box. Now we're going to do the area of the green box. And for your homework, when you're doing this, you could even label them, this box number 1, 2, 3, and 4, and then you could say area of box number 2, area of box number 1. Alright, so the area of the green box, here's another box that we have. And we need to know the dimensions for this. So we have to look on our drawing, and let me just adjust this so you guys can see the dimension strings. Alright, so it looks like for the green, I'm going to follow it down. Okay, we're looking at this dimension, and we have to come all the way over to, well, we've got one that runs to the center line. So we're gonna go ahead and say that, and we're gonna get 14 foot 1. So 14 feet 1 inch by, we need to look over here at this dimension. Move that back up so you can see. So this dimension over here, we've got now this goes to the center line, so it's going to be a little bit off. Not like a huge fan of the way this is calculating, but that's okay, we'll go with it. So we'll do 13 feet 10. So the area of the green area is going to be equal to the length times width. So area is equal to 14 feet 1 inch times 13 feet 10 inches. And our area is going to be, if we take a look at our construction calculator, 14 feet 1 inch times 13 feet 10 inch equals 194.8, I'm going to say 82 feet squared. So I'm just going to round it. If I round that one to 2 decimal places, I might as well change it up here. So we'll do it 798.06 feet squared. Okay. So then we'll go back to the next box. So we're going to do the black. So we have another rectangle type shape here. It looks like it's about 10 foot 3 inches by, do we have a dimension? Yeah, you're going to have to subtract. So actually, if you look over here, this dimension of this blue box is 12 foot 11 and 3 foot 6. So we're going to have to take 12 foot 11 inches plus 3 foot 6 inches. So we can do that. 12 feet 11 inches plus 3 feet 6 inches equals 16 feet 5 inches. So that's actually, of the blue box, that's the length. But I need that because you're going to see that this black box starts or ends at the same point as the blue box. And then I have to subtract out this 2 foot 8 dimension over here because this is all earth. There's no foundation in this zone. So minus 2 feet 8 inches and 13 feet 9 inches. So that would be our, so we're going to do the area equals length times width. Area equals 13 feet 9 inches times 10 foot 3 inches. So the area is equal to 140 point, I don't know, I'm having trouble. 140.94 feet squared. Okay, black box. Now we have to do the blue box. So then we have the blue. On our blue box, we actually determined the length before. It was the 12 foot 11 plus the 3 foot 6. So that is going to be 16 feet 5 inches. And then we need this dimension down here, which is 14 feet 2 inches from the drawings. Okay, so area is going to be equal to length times width. So area is equal to 16 feet 5 inches times 14 feet 2 inches. Oops. So we have 16 feet 5 inches times 14 feet 2 inches, and it's going to be equal to 232.57 feet squared. And then lastly, we're going to add all our areas up to get our total area. So, okay, sorry, let me rotate this so you can see it. So now let's add that up. Okay, so we have 798.06 plus 194.82 plus 140.94 plus 232.57 equals, so we have a total area of 1,366.39 square feet. And you might be a little bit plus or minus that depending upon how you divided the spaces up or some of the dimensions that you took. In construction, the interesting part, and you'll learn this in cost estimating, is that we usually go over by 10% when we order materials anyway, so that we don't run short. So it's good, you have to be close to the number, but sometimes if you're a little over, it's okay. Question number 9, it says, why would a row of large evergreen trees between the lake house and the lake decrease energy efficiency of the house? So I want you to go ahead and just think about that answer in terms of efficiency. Think about what you've read before in the chapters. You might need to look something up online, but that answer is something that I want you to investigate on your own.